The recent report was of a mixed-race woman who had HIV and was on treatment for her HIV and then developed acute myeloid leukemia, a type of blood cancer. And to treat the leukemia, she received a transplant, a bone marrow transplant, but it was what we call a mixed transplant. It had regular cells from another adult, and then it had cells from cord blood, from a placental cord blood, and that cord blood cells came from a donor who's naturally resistant to HIV. And then the transplant was performed. She stayed on antiretroviral therapy for a number of years, and then they were unable to find any evidence of virus in her blood, and she stopped her antiretroviral therapy. And usually virus would come back in 2 to 3 weeks, but it's now been 14 months and there's no evidence of the virus. And so this has been described before. It's been described previously in 2 men, but they received a different kind of transplant. They just received the adult donor transplant. And the reason why this is exciting for people is, first of all, it's a proof of concept that you can cure HIV. And second is that this procedure that the woman underwent is far milder procedure than what the first 2 cases underwent. Now, does that mean this is a cure for everyone living with HIV? No, because it's still a very significant invasive procedure. It's suitable for someone that has HIV and cancer together. However, this case does put us on new paths for discovery of finding a cure for HIV using different approach, but learning from these cases of cure following transplantation.
How much was it dependent on the donor being naturally resistant, as you pointed out, to HIV, which isn't that common?
It was very dependent on that feature. So the first 2 cases that were described also came from a donor that was naturally resistant to HIV, meaning that they lack the receptor HIV needs to enter a cell. And then on average, that mutation occurs in about 1% of people, of Caucasians, and even lower levels in people of other races. But that was key to the success of this transplant, I think. Now, only the stem cells, only the cord blood had that defect that were naturally resistant. But the cord blood, basically you were transplanting with 2 different transplants, and the cord blood won over time. By 100 days after the transplant, 100% of this woman's cells were of the donor of the cord blood.
That's fascinating. So what is it going to take to make this apply to patients with HIV, but not necessarily another health issue?
Well, I don't think that we would ever do a transplant in someone with HIV and no other cancer. But what this tells us is if you can knock out the receptor for HIV, this way done by transplantation, and that receptor is called CCR5, you can effectively make someone's cells resistant to the virus, and the reservoirs of the virus that we know are very hard to eliminate will actually disappear. So we have other ways that we can knock out the receptor for HIV using gene scissors. And there's lots of advances now in gene therapy or gene scissors to knock out a gene, and that's a very active area of research currently.
Is it something that is very scalable, given the bulk of people living with HIV are probably in Africa, for example, where health systems would really struggle to support this level of intervention?
Yeah, it's not just a matter of the economic situation of the country you're living in. People living with HIV on antiretroviral therapy have long and healthy lives, and so therefore an intervention like a bone marrow transplant, even with a cord blood transplant, which is has fewer side effects, is still very significant, and it just wouldn't warrant that sort of intervention. Now, what we would do, though, is learn from that observation to make an intervention that could be scalable. And indeed, gene therapy, pretty complicated now, but a lot of work globally to actually make it scalable. And that may well be possible and may well be available to people living in low-income countries in years to come.
So what is the next part of the research stage, and what sort of timeframe are we looking at?
First of all, this woman is one of a cohort of 25 other people who will receive stem cell transplants from a donor who's naturally resistant to HIV should they get cancer. So that will be available to people with HIV who will get cancer over coming years in the US. So we will learn a lot more from these other cases that we will hear about in the years to come. But the real exciting area is that this fuels the idea that larger gene therapy using gene scissors to eliminate the receptor for HIV could be a viable strategy towards a cure. Now, those studies are already underway. Currently, how that's done is someone with HIV will have a large amount of blood taken out from their bodies. The cells are edited or manipulated externally, and then the cells are reinfused into that person. Those studies are being done now, and they appear to be safe, but it's been difficult to get the number of edited cells up to very high levels. But there's new ways of delivering gene therapy that might not require you to take cells outside the body. There's really exciting advances in the broader gene therapy world that we hope will also benefit people with HIV in the long term.
Really fascinating. Sharon, thanks so much for taking us through that.
Thanks very much.